All right, we're going to talk about section 4 from chapter 15, the last one, surface area and volume of similar solids. All right, essential question: when the dimensions of a solid increases by a factor of k, that means it's constant, guys, how does the surface area change? How does the volume change? Okay, some new important vocabulary, this word similar. You guys have seen me talk about the symbol for that. It's just the one kind of squiggle, all right? Similar solids are solids that have the same shape and proportional corresponding dimensions. So they're the same shape, just not necessarily the same size. All right, so let's look at example 1. It's about identifying similar solids. Which cylinder is similar to cylinder A? So cylinder A has a radius of 6 meters and a height of 4 meters. So we just kind of have to compare our measurements. All right, so let's do A and B first. All right, so what do we know? We know the height and we know the radius. So we can talk about the height of one over the height of the other. So the height of A is 4, and then the height of B is 3. And we're trying to see if that's equal to the radius of A, which is 6, over the radius of B, which is 5, okay? Important that you set your proportion up correctly. I did height over height, radius over radius, A over B, A over B, okay? I did A over B. So give yourself a little, words first to set up your proportion. Cross multiply and you get 18 and 20. So no, A and B are not similar because their measurements are not in proportion. So let's talk about A and C now. Okay, and we can do the same thing here. We'll put all the dimensions of A over C. So the height of A is 4, the height of C is 5, and is that equal to the radius of A, which is 6, over the radius of C, which is 7.5? Is this a true proportion? 5 times 6 is 30, 4 times 7.5, oopsie, I started writing that, is 30 also, so yes, okay? That is a proportion, so cylinder C is similar to cylinder A, okay? They're all cylinders, but A and C have corresponding sides or corresponding dimensions that are proportional to each other, okay? All right, so now we can use that whole idea to find missing dimensions. Here it says the cones are similar. You need that information to be able to set up a proportion. By me saying they're similar or the directions telling you they're similar, you're able to know that everything's proportional, and then you can set up and solve a proportion. All right, so we know that we have cone X and Y, so I could take cone X and put it over the information from cone Y. We have the radius of each and the slant height of each, okay? So I can do radius over radius equals slant height over slant height and solve for my unknown slant height here. So the radius of X is 5 over the radius of Y, which is 7, and is that equal? Yes, it is, because we know they're similar. The slant height of X over the slant height of Y, which is my unknown, and they have a cursive L there. And then solve your proportion. 5 times L equals 7 times 13, which is 91. Divide both sides by 5. L is equal to 18.2. So the slant height of cone Y is 18.2 yards. Do not forget your units, okay? All right, I want you guys to pause it, and you're gonna go and try these few on your own. Just a quick reminder, question 1 is referring to example 1 here. They're throwing in another cylinder, a 4th cylinder, so cylinder D, okay? All right, go ahead and pause it and give those 2 a try. Alrighty, hope you gave them a shot. Question 1, the answer is cylinder B. Okay. And then question 2, the width was 3.2 inches and the length is 4.4 inches. All right, so if you didn't get those answers, try them again. Set up some proportions, okay? Just make sure, you're consistent, you use words first. These ones were all labeled X and Y. You can do stuff like that. You can make this A and B. You can make this one big one over small one. prism 1, prism 2, whatever you need to do to help you stay organized, okay? So that's dealing with solids that are similar and looking for missing dimensions. Let's go over here to the next bit, and I know this is small because I wanted to squeeze it all into 2 pages. The first key idea is talking about measurements of similar solids, so dealing with surface area, okay? When 2 solids are similar, the ratio of their surface areas is equal to the square of the ratio of their corresponding linear measures. So you have the surface areas over each, and then whatever dimension they give you, you need to square them because it's area. So the same applies for volume, except obviously we'd be cubing those dimensions, okay? So let's give these a try. So if we look at example 3, it's talking about finding the surface area. Again, they're telling us that the pyramids are similar. So we're good to go. We want to know what the surface area of pyramid A is. Okay, well, I don't know, but I know the surface area of pyramid B. So you could do, surface area over surface area again. So we could just do A over B. So the surface area of A, I don't know. The surface area of B, I do know. That's 600. And then the dimension that they've given us is the height. So the height of A, because all of our A's go on top, is 6. The height of B is 10, but because we're dealing with area, we need to square it, okay? So you have to square it before you solve it, okay? So S over 600 equals 36 over 100, and then solve your proportion, right? Do your cross multiplication, and you get S is equal to 216. So the surface area of pyramid A is 216 feet squared. All right, so you square the dimensions. Why? Because it's area, okay? Think about it. The surface area is already squared, so we need to square the dimensions to keep it proportional. All right, let's look at example 4. It's dealing with volume. So same setup, except we cube the dimensions now. It says the dimensions of the touch tank at the aquarium are doubled. What is the volume of the new touch tank? Okay, so the old touch tank is half the size of the new one. Okay, so we can do, we don't have A and B's or X and Z, so we have original over new for this one, you guys. So the original volume is 2,000 over the new volume that we don't know. And since they doubled it, right? Or since the original one's half, we can use the ratio of 1 over 2, and we're going to cube that because we're dealing with volume. All right, so when we work this out, this would be 2,000 over V equals 1 over 8. Solve your proportion. V is equal to 16,000. So we know right here the answer is D. The new touch tank's volume is 6,000 cubic feet. All right, here's a couple down here for you to try on your own. The solids are similar. Make sure you always have those directions. You're going to find the surface area or volume of the red figure. Okay, so again, organization, put blue over red, whatever you need to do. I know this is getting a little bit blurry. My printer's getting a little low on ink. This dimension here is 8 meters, and this is 608 meters squared, if that helps you, okay? So go ahead and pause it and give these two a try. All right, I hope you tried them. I'll show you the setups and then I'll give you the answer. We could do blue over red. Okay, so the surface area of blue is 608. I don't know the surface area of red. The dimension provided for the blue one is 8. The red dimension is 5. It's area, so we have to square them. Okay, so that's the setup. The answer is 237.5 meters squared. So that's the surface area of our red figure. Question 5, the setup. Again, we can do blue over red. So the volume is 288 over the unknown volume. The height is 12 over the height of the red one, which is 5. This is volume, so we need to cube the dimensions, okay? Cube it all, then solve your proportion, and you get 20.8 cubic centimeters for your volume of the red cone. All right, I hope this helps. Give them a shot, and I'll talk to you soon. Bye.